Today's lesson is on 2.4, factoring polynomials. If I look at the numbers 12 and 24, we want to be clear what factors are. Factors are numbers that go into another number. So numbers like 2, 3, 4, 6, 12, all of those numbers go into 12 and into 24. I can multiply those numbers by something to get either 12 or 24. So those numbers are factors of 12 and 24. So we don't want to get factors confused with numbers that 12 and 24 go into. I can multiply 12 or 24 to get any of the numbers 24, 48, 72, and so forth. So 12 and 24 go into those numbers. So those numbers, 24, 48, and 72, are multiples of 12 and 24. So when we're factoring, looking for the factors. So our first term that we want to be clear on is greatest common factor. And we usually abbreviate that GCF. So we're looking for factors, okay? Numbers that go into the numbers that we have. So we might be asked the question, what is the greatest common factor of 12x to the fifth plus 8x to the fourth minus 6x cubed? Well, first we're going to look at the numbers 12, 8, and 6. We want factors, numbers that can go into all of those. So the biggest number that can go into all of those is 2, because I can multiply 2 times 3 to get 6, 2 times 4 gets 8, 2 times 6 gets 12. 2 goes into all of those. Now I want to look at the variables. X to the fifth, x to the fourth, x to the third. What goes into all of those? Well, obviously x does, but the greatest common factor is x to the third. It's not x to the fifth because you can't go x to the fifth times x to the something and get x to the fourth when we're only dealing with positive exponents. So x to the third is the greatest common factor for the x's. So for that polynomial expression then, our greatest common factor is 2x to the third. That's the answer. All right, I want you to try to find the greatest common factor for 15x squared plus 18. Do you have it? The numbers 15 and 18, what goes into both of those is 3. Only one term has an x. The other term doesn't have a variable. So we can't use x as a common factor because it's not common to both of them. So the greatest common factor is 3. All right, try this one. Negative 18y to the fourth plus 6y to the third plus 24y squared. What's the greatest common factor? If you need to, pause the presentation, figure that out, and then restart. The greatest common factor is 6y squared. 6 goes into all of the numbers. Y squared goes into all of the variables. Now, another way we may ask the question, but with a little bit different answer, is factor out the greatest common factor for the polynomial. So we have a problem like negative 12x cubed plus 18x squared minus 27x. So we're going to factor out the greatest common factor, but rewrite the polynomial in the factored form. So for 12, 18, and 27, the greatest common factor is 3. 3 goes into all of those. And then for the variables, the greatest common factor is x. Now, 2 of those numbers have a negative number. So conceivably, I could factor out negative 3. So I factor out negative 3x, and negative 3 times 4 will give me the negative 12. Negative 3 times negative 6 will give me the positive 18. And negative 3 times 9 will give me negative 27. So we really have to be careful watching the signs. Okay, try to factor this one. Negative 16y to the 6th plus 28y to the 4th minus 20y to the 3rd. Pause the presentation, factor that, and then resume. If I factored out a negative, then factoring out negative 4y to the 3rd leaves me with 4y to the 3rd minus 7y plus 5y. Now, if I didn't factor out the negative, I could have just factored out the positive 4y to the 3rd. And then my signs would be the same as the signs in my original polynomial. So when you factor something out, you need to be cognizant of the signs. You need to pay attention to the signs. Okay, try this one. Pause the presentation, factor out the greatest common factor, and then resume the presentation. That factored is x times x squared plus 5x minus 22. Each term has a variable, but the first term does not have a coefficient other than 1. So we can't factor anything out that's common to 1, 5, and 22 other than 1. Okay, factor this one. Pause the presentation, factor it, and then resume. Okay, here in this one, our coefficients are 15 and 10, so 5 is common. They both have an x, and x squared is the lowest x, so x squared is common, and they both have a y, and the lowest y exponent is 1, so y is also common to both terms. So factored, that's 5x squared y times 3x minus 2y squared. Now, in this problem, we have Alani, who is in charge of marketing for a travel company. She's designing a brochure that will have 6 photos. So the photos can be arranged on a page in a different number of ways. Now, there's 2 square photos. Each of the square photos is x inches on each side. And then we have 4 smaller photos. Each of those is 1 inch by x inches. So here's the question. What's the total area of the photos? Well, the total area is going to be the area of the square photos plus the area of the narrow photos. So the area of each square photo is x by x, or x squared, and there's 2 of those. The area of each smaller photo is 1 by x, and there's 4 of those. So we have 2 times x squared plus 4 times 1x, which is 2x squared plus 4x. Now, is that our answer? The question said, what is the total area? And we were given units. So the total area is 2x squared plus 4x square inches. And so in our answer, we need to remember the units. The next question is, what's a rectangular arrangement for the photos that we can make, and what factoring would represent that? Well, making a rectangle, we could just put all the photos in a row. And so the square is x by x. So we have x on this side of the rectangle, and then we have x plus x plus 1 plus 1 plus 1 plus 1. So we have 2 x's plus 4 on the bottom. And so a polynomial that would represent that is the x times 2x plus 4. So now the next question, factor out the greatest common factor for the polynomial. And what does that greatest common factor represent in this situation? Okay, the polynomial is the 2x squared plus 4x. So we want to factor out the greatest common factor. So for the 2x squared and the 4x, the greatest common factor is 2x. So rewriting that expression, we get 2x times x plus 2. So now looking at this picture then, putting that into this factored form, the 2x, we'd have two x's on this side, and the x plus 2, we have the x of the square, and then 2 of the narrow photographs. So the 2x represents the height of that arrangement. And then the x plus 2 is the width of that arrangement. Okay, here's something for you to try. Suppose that the dimensions of the narrow photos were increased so that instead of being 1 inch, now they're 2 inches by x inches. If that's the case, what's the expression that represents the new arrangement based on the greatest common factor? So figure that out, pause the presentation, and then resume what you have. Okay, if these photos are 2 inches, then in this kind of arrangement, we'd have x plus 4 inches, and we'd still have the 2x's factored out. So our arrangement would be 2x times x plus 4. The 2x is the greatest common factor. So greatest common factor should be pretty easy. But it's important that we focus on this because when we do other factoring, we always want to look for the greatest common factor first. So now, let's do the classwork or the Pearson assignment that's been assigned to you. Go get them.